the go live button. Boom. Okay. I think it is live, everybody. Thank you so much for tuning in to check this out. I'm excited to have some opportunities to do some hardware hacking with an audience. I think that should be fun. Um, yeah, so I have in the corner down here, there's a camera that's pointed directly at the LED light that we're going to be working on tonight. I have the controller app running on my computer, so you can see when I hit the button, light turns on, I hit the button, light turns off. There's a couple milestones that I'm going to try and work through tonight, and hopefully we can replicate some functionality with Rust, right? So let's take a look at what we're going to try and do tonight. So number one goal is write some code that can make the light turn on. That's the simplest thing, right? And next step, make the light blink. If we can add some timing code in there, that I think is going to be slightly more interesting than just having it turn on. That one should be relatively straightforward. Next is make the light blue, which should be somewhat more of a challenge because we'll have to figure out how we can send color information to the light. And then the next one is make it blink blue, pink, white. And I think if I can get to all four of these tonight, that is going to be a really successful night. I'm not sure if I will be quite that successful, but at the very least, I want to be able to turn it on and probably make it blink as well, because I think those two are going to come together very well. Hello, Miguel. Thanks for tuning in. I hope that you enjoy reading the new chapter of Refactoring to Rust. That is the first chapter that has been written and published by my lovely new co-author, Joel Holmes, who has some previous experience writing some Go books for Manning, and I'm really excited to have him on the project. So the first thing that we're going to need to do if we are writing the Rust code to control the light is I'm going to need to figure out how to, I'm going to need to kind of look at the protocol, right? I'm going to need to control the light and look at the Bluetooth commands that are happening. So I know I teased, and I know the title of this says Wireshark. We're not actually going to be using Wireshark because the macOS Bluetooth stack actually doesn't expose any interface whatsoever that libpcap can use to capture Bluetooth traffic. So we are going to be using the macOS exclusive app packet logger in order to try and capture this Bluetooth information. Hello, Rod. Thank you for tuning in all the way from Brazil. That's pretty cool. So this is Packet Logger. This is macOS's debugging tool that they provide to developers for logging Bluetooth traffic. I believe it comes alongside Xcode. It's available for anybody who's on the in the Apple Developer Program. It is free, but because it's an Apple thing, maybe it doesn't have the best documentation. So we're gonna have a little bit of a trial and error process over here. So I think what I'm gonna try and do is disconnect from the device over in my controller app, and then I'm gonna start monitoring for Bluetooth traffic. And wouldn't you look at that? There's a whole heaping load of traffic that comes through. And I'm gonna connect to the device. Ooh, and it just got real interesting when I did that. And I just went ahead and stopped recording as soon as I got all that stuff. Let me see if I can make sense of any of this. So I have the device MAC address ends in wait a minute. The device MAC address ends in C994. Oh, here it is. It was backwards. Interesting. Okay, so we've got some advertising reports So the structure of Bluetooth LTE, based on the minimal research that I conducted several days ago and did not check before I started streaming tonight, told me that the normal flow of information in Bluetooth LTE is you have devices that are constantly kind of broadcasting advertising packets out across the network, letting everybody else know this is what my device is capable of. And so it looks like that is what we have over here. So we have some manufacturer information. We have a packet that says, or we have a name packet that says it's a Bluetooth LTE device or Bluetooth LED device. And then there's going to be a connect packet probably somewhere in here. MTU, read by group, primary service declaration. Ooh. Let's see here. There's data, error response. Okay. Request. So this is a send from my computer to the device. Okay, so we are sending some like configuration information down to the device initially. All right, let me see if I can capture what it looks like when I turn the light on, because that is probably going to be slightly more interesting than just connecting to it in the first place. All right, so I've connected, and let's restart packet capturing, and boop, we're going to turn the light on. And let's stop recording. My filter does not seem to have actually. That is very interesting. I'm sorry. The first connection handle. I'm stumbling my way through this thing because I am not super familiar with Packet Logger, but this may or may not be super interesting for you to watch. Thank you so much, my 3 concurrent viewers. Let's see what we've got going on here. All right, maybe what we could do is jump over to Rust and see if we could enumerate any kind of information from the Rust side. So let's jump back over to VS Code, and we have just a totally empty Rust project to start with. And I think the stuff we're going to need to begin is the BT LTE plug library and probably Tokyo. So let's start with Tokyo. Tokyo features full and cargo add BT LTE plug. I must have misspelled the name of it. BTLE plug. Extra T. BTLE plug. Beautiful. We've got our Tokyo main function. And let's also add an error handling. I don't have to do that later. Beautiful. We have the skeleton of a main function that knows how to handle errors. That should make things a little easier. So let's grab a manager from the Bluetooth library. This is going to allow us to grab must include the din keyword. Yes, I grabbed the trait instead of the concrete type. So this is going to give us like a handle to, this is the superstruct. This is the thing that does absolutely everything in the library. Sometimes you have libraries that have small surface areas. It looks like this Bluetooth library is a library that has a pretty big surface area, right? It's got a struct called manager, so it's business grade, right? we're going to grab the list of Bluetooth adapters. These are going to allow us to actually talk to Bluetooth things. And we are going to pull the first one off the list. And we're going to import the trait so that we can actually call trait methods on it. And I, once again, mixed up the trait and the concrete type. So if you have a trait and you have a concrete type with the same name, usually you can just import the trait with its name. But if you have a concrete type that has the exact same name, you can use this little as underscore syntax right here to not actually import the trait by name. So you can't actually refer to this trait by name in this code, but you can use all the methods that are inside of it because call the trait methods. Traits need to be in scope in order to have their methods called. And the adapters method on this manager is coming from the manager trait. All right, so we have a Bluetooth adapter, and we want to look for devices that are nearby and are ready to be connected to. So in order to do that, we can run a scan, a Bluetooth scan, and that is also coming from the library. And because I don't actually know the smart way to do this, because I don't know the vendor code or anything, we're just gonna scan for absolutely anything, and we're gonna wait for 2 seconds. And that is hopefully gonna be enough time for the advertising packets from the light to get to my laptop. Yeah. So I'm copying and pasting tons of code from the README right now. As you can see, where local name, yeah. Any local name, where oop. And we're just gonna debug. Just gonna print out that local name. And there's probably another trait for that too, the peripherals trait. All right, and we should be able to run this in this state right now. It should give us maybe a little bit of information, at least about what kind of devices are nearby. So we do cargo run. And of course, this is going to compile all of our code, bringing in our dependencies. And hopefully this should print out information about that light. At least the name would be good. There's my phone. There is the light that's behind me on the wall. There is my HomePod. There's my watch. I don't know what that is. Beautiful. So we don't have, our light is not showing up in the list. Okay. So I wonder if I can actually just print out all of the properties. What is this? Peripheral properties? Maybe that implements debug. We'll see. We'll see what we get. Peripheral properties, address. Oh yeah, this other weird quirk that the library's documentation mentioned, it actually doesn't support showing the MAC address for peripherals on macOS. So I'm not sure if there's some APIs that the OS is hiding, or if it's just actually a limitation of the library itself. But for some reason, the Bluetooth library on macOS, the BTLE plug library on macOS does not expose MAC addresses. So I'm not able to just like refer to the number and say like, oh yeah, this is obviously the right device, the device that I want to connect to, because that information is not available to me, which is mildly annoying, but we'll get there. We'll get there in the end. Let's see here. I wonder if Packet Logger gave me like a manufacturer data packet that I could use to identify this particular device. Let's jump over there and see if there's anything like that I could pull out. Whoa. Indiscoverable appearance. Not seeing anything in there. manufacturer. Let's see here. 16-bit UUIDs. Skip mode. I'm wondering if it's because I'm connected over here in this application and that's limiting visibility. Let's try this one more time. So I disconnected the controller app from the light, and I am now, I reran the scan from the Rust side, so I'm going to see if that is going to allow the device to show up. I believe it had an actual local name when I was looking inside of Packet Logger, so I'm hoping that that will show up over here as well. There it is, BT LED. That is the thing that we are looking for. So what I'm going to do now is I'm going to connect to this device. So we've got a local name, if local name, BT LED, and we're going to do expected string found stir. Can I do that? No, I can't do that. I can do as ref, which is what I should have done in the first place. Expected reference string found reference static string. Okay, well, how about if that's fine. I probably, okay. We'll do that. Wait, can I do this? Does that work? No, that doesn't work. Of course that doesn't work. Does this work? No, of course that doesn't work. I see. Parsing the value, that's fine. Value set device is never read, that's fine. We're gonna start reading it now. Now that we have the device in an option, let device equals device all in rack. You know what? No, we're not gonna do it this way. We're not gonna be gross. We're not gonna use unwrap. We're gonna pull this out into a helper function that has its own error handling. Okay. Find LED central. That is something, and we're returning as something else. We're returning a result, something, and return okay. This is a something, and if we fail to find a thing, we're going to return an error because we failed to find the thing. Didn't find a thing. And bail is a macro that's coming from the error library. Oh god, I don't know if this is good or not. I feel like I'm typing very fast. I don't know if this is followable for anybody. Can somebody in the chat tell me if this is possible to follow my ridiculous ramblings through all of this? Anyways, we're using the helper function now. Find LED, we're passing in the central. It's gonna need to be an async function. Central. it's an adapter. And it's a peripheral that we're returning. Must be inside thingy. LED. Wait, what actually is this thing? Is it a concrete peripheral type? Can I concretify this? It is a concrete type. Some libraries make this choice, and I'm not quite sure how I feel about it, but sometimes well, I said like it definitely makes testing a lot easier when you do this because you can swap out I guess especially with something like Bluetooth, that would be important, right? Having a concrete type that actually talks to the like real network interface, and then we also have a trait that has the same name that has all the methods on it, and we have an implementation of those methods on the concrete type. Like it makes library implementation a lot easier. We definitely do this for some of our stuff at work. But it does make using the library a little bit slightly challenging if you do not understand that dichotomy exists for tons and tons of types. All right, so let's see what we've got going on with this LED, right? Let's look at let's discover the services. So Bluetooth LTE has a concept of services, which are basically like pieces of functionality on a device that you can read and write data to and from. So let's see what we've got going on in here. So this is basically just a future that's going to run and finish when we've discovered all the services, including their characteristics. So we're going to loop through these services now and see what exactly we've got going on. For service in led.services. And what does this return? It returns a B-tree set of services. Can I debug the service? We'll see. Doesn't look like we found any services. Let's debug the device as well. Let's debug a reference to the device so that it doesn't get moved and we can continue to call methods on it. I think that's a good idea. Okay, so it does look like there's two services in the debug representation of this device. I'm not entirely sure why those are not showing up in the later. Yeah, because this is the LED, it's not a service. I'm not sure why it's not showing up in this debug thingy. It seems to me like it probably should be, but that's okay. I'm sure we can figure it out. Yeah, look at this. There's nothing in this services. This is like empty, but then this services, ooh, this has some UUIDs in it. Those seem important. Those seem good. Are those good? I think they're good. All right, we've got the service UUIDs. Why are the service UUIDs showing up in the properties, but they're not showing up in the services list? Are those two things the same? Let's see if I can find any interesting information in the documentations. Services. Okay. So the services property of a device is labeled as advertised services of the device. But peripheral services trait method, set of services we've discovered. This will be empty until discover services is called. But I call discover services and I wait for it to complete. So discover all the services, including their characteristics. And I even like I'm giving up if there's an error, but the error isn't happening. I also want to get rid of this because I'm annoyed by sleeps. So what we're gonna do is we're gonna do a little gonna do a little sneakiness over here. We're gonna start the scan. I'm gonna say if that okay. LED equals find LED dot await. And then I'm going to turn that into a reference in a second. Find LED. This is going to take a reference to an adapter instead of an adapter. And let's minimize this down here. All right, so this is going to get rid of that annoying 2-second sleep at the beginning. Try and hopefully minimize the amount of time we have to spend scanning. That was much faster. It looks like the services still are not showing up in the discovered services, which is a little, I don't know, rather confusing to me. These services have the same UUID suffix, which I believe from my investigations I learned was some kind of standard suffix that exists for most kind of UUIDs. So I think the interesting part is, well, it's actually there's only one byte that's different. This is this one right here, 0F versus 12. Okay. I'm trying to discover the services. They're not showing up, but they are showing up in the properties list. What if I debug it down here? Is that going to give me anything different? Services are still showing up in there. Still not getting the services message to print out below. So yeah, it hasn't actually discovered the services. Okay, well, how about I run discover services many, many times? No, that doesn't work. Shocking. I'm shocked. I'm horrified. I thought I could run this discover services method as a bunch of times, and that would solve all my problems magically. But no. Horrendously, atrociously, that did not work. I have to get the actual type back. I can't just fake it. I can't just grab this UUID and feed it into the library, because the library needs me to give it it needs me to give it an actual type. What if I look at the properties? I wonder if this is going to have anything different in it. I'm guessing not. Yeah, it looks like this is the same information as I was getting before. It's interesting that this method, that is an async method, appears to have its output in the debug representation. I'm not really sure why they would do that to us. Hello, Marshall. Yes, I'm hacking. Well, I think I'm being hacked right now. That's what's going on. Yeah. Sometimes you hack life, and sometimes life hacks you, unfortunately. It seems the library is not giving me back the information that I want it to give me back. Let's do this. No, I can't do this. This is a B tree set, so I can actually debug the whole thing. Because you know what? Maybe it's not a bug in the Bluetooth communication at all. Maybe there's a bug in the debug implementation of the B tree set collection, the standard library. Surprisingly, that turned out to be false. Or no, I'm sorry, not the debug implementation, the iter implementation. Somehow the standard library did not have a bug in its iter implementation. So services is in fact returning nothing back. That feels like a little bit of a brick wall, because I need something to be in there. I need A services to connect to, because I get, oh, wait a minute. Oh, can I just construct these? You know what? I might actually just be able to construct these. I might be able to cheat this a little bit. Okay. So the thing that I actually need to be able to do is I need to be able to call the read and the write method. And that looks like this. I need to pass in a characteristic. I need to pass in the raw data that I want to write, and I need to pass in the write type. And a characteristic is actually a thing that has like, it just has a bunch of public fields on it. It doesn't have any like magical arc reference to the outer manager or whatever. So if I really wanted to, I could potentially just like sniff all this information off the wire and like just grab it. So maybe we'll try to do that. Oh, wait a minute. Hang on. Was there something even sillier that I forgot to do? I think there was something sillier I forgot to do. You know what I did? I found the LED. I found the peripheral. But what did I not do? I didn't connect to it, which I think might be necessary in order for this Discover services to work correctly. I'm not sure. That's 100% a guess. But let's see if we get anything different. Yep, that's exactly what I had to do. Beautiful. Okay. Goodbye, debug properties. I'm done with you. You're canceled. I'm moving past you. I'm at a different point in my life right now. I'm so sorry. Okay. We have two services. We have they're both labeled as primary. One is a read-only property, and one accepts write requests. So almost certainly this is going to be the service that I care about writing to, because it's the only one that I can write to. This is a read-only property. Who knows what in the world this reports out of it? Oh, it might report battery information because this light does, it does accept like camera batteries you can slot into the back of it. So this might maybe report battery level information. Yeah, but that doesn't matter. There's no batteries in this. It's plugged into the wall. What we care about is making it blink. We want it to wink. We want a cute little glance from this light. So let's see if I can copy this UUID and potentially use that in order to, oh no, I bet I don't even need to do that because I can iterate over the characteristics and find the one that has, no, I'm not going to do that. I'm going to copy the UUID because that seems like the right thing to do, doesn't it? Services have a UUID. That is the UUID library. We'll go add UUID. Const UUID from let's see. I want to find a const method because I need to save those nanoseconds. This is a very important and fast program. Try parse. Oh. Const fun. I don't want try parse. No. No, I want a function that runs in constant time that I can put in a constant at the top of my file from bytes LE. Sure. Yeah, we can do that. From bytes. What I'm gonna do. And I need to give this a byte array. Yes. And what's my UUID? Here it is. Let's feed this in. Yeah, yeah, yeah. Ooh, yeah. Doot, 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 doot. Uh, so many commas. Anybody in chat points out to me that I'm using Vim key bindings and I shouldn't be working this hard and banning me from my channel. Okay, I have a UUID. Let's use this to load that service. Let's write a helper. Service LED peripheral result service. I don't think I want an API service. I probably want a peripheral service, which is where the concrete types live. Or sorry, a platform service. I'm assuming, nope. So who knows what in the world? Oh, that's right. The services were just like, these are just like a silly, yeah, okay. So that is where it is. I'm sorry, Rust Analyzer. I doubted you. I'll never do that again. I feel so ashamed. Okay. We're connected. We're discovering. We're iterating. Now we're iterating. We're looking at the services. If service dot UUID equals service UUID, return a service. Fail didn't find service. Let service equals find service ID. No. There it is, folks. All I had to do was actually remember to connect to the device. I feel very silly, but it's okay. We got there in the end. I probably would have figured it out eventually, because I'm sure the write requests would have failed if I wasn't connected to the device. But you'll have that. Okay, we've got the service. Service has a number of characteristics. So this service is probably something like the control the light service. And these characteristics represent individual data points. So I'd be willing to bet that one of these is the color and the other one is the intensity. But I have no idea which is which. And I have no idea what the structure of the data going to each one of those characteristics is supposed to be. It might just be like, you know, there might just be a single byte for intensity and I don't know, whatever the normal number, 3 bytes for color. Okay, so this app is ended, which means the actual control app is going to be able to connect, which means what we are going to do now is we're going to jump back over to Packet Logger. We're going to connect to the device. We're going to send it some on-off like flippers, and we're going to see what happens on the Bluetooth side when we do that. So let's cut the video feed over. All right, controller application is connected. Let's start recording. Boop. Oh, we're going to turn this off and we're going to turn it back on. And then boop, we will pause that. And right. Oh. Wait a minute, what is this? Is this handle perhaps attached to the device? We'll find out. Do I think the API would be better if they use the type system to match the state of the interaction, like connected device or something? Yeah, I think maybe it would, but well, it would have protected me in this particular case, but I think in general it wouldn't have protected you because, the reality is that we're dealing with we're dealing with wireless devices, right, that are separate from the computer. So like it would be, I think, overly optimistic to expect the type system to be able to model the state of a connected device at any point, like whether or not the device was connected, because the device could lose power, the device could be physically walked to a different location that's out of range of the computer, and you know the type system might say it's a connected device because you called the connect method, but the device might not actually be connected, right? Like I think the actual thing to do is like periodically there's a is connected method on the peripheral trait in BTLE plug. And I think that the correct thing to do is like periodically call that method and make sure that your device is actually connected. And I assume, the read and the write methods will actually feed us back some kind of error information if we are trying to send or receive data from a disconnected device. But let's see what we're looking at here. Let's see what's in these beautiful, beautiful data packets. It's really buried deep down there. R LT 0W close quote. Thrilling. Channel ID. Does this have the characteristic ID in it? Looking for what is the character? Oh, wait a minute. Characteristic, actually, there actually is only one characteristic of this service. It has two descriptors inside of it though. So I need to figure out what descriptor this is being written to is. The two descriptors, the first like bit of the UUID ends in 2901 for the first descriptor and 2902 for the second descriptor. So I'm looking for 2901 or 2902 somewhere in this list. And yeah, we'll see if we can find anything in there. Output 52, 2902, 2902. I'm also slightly afraid that it might be established at a higher level. Like, no, because this is a connection. It should probably be in here, I would hope. 2901, 2902. L2 cap. Oh, channel. Wait, 5211. Is that anything? Do I know what that is? I don't think I know what that is. Yeah, I don't think I know what that is. Oh, wait, but oh, no, it is hex. It's hex. So let's see here. If anyone's very familiar with Bluetooth stuff, feel free to tell me what very obvious thing I'm missing in the chat. Otherwise, you're welcome to watch my misery. Sometimes. Oh, wait, this is interesting. Let me see here. How many times did I turn the light on and off? I'm going to clear this and retry. Okay. Off, on. On, on. Okay. I'm seeing something here. I'm seeing slight differences in this write command. Oh, it was actually the response that I was getting. That must be telling me if it's on or if it's off. So let's look at this write command here. You know what? There's only 2 descriptors. Why don't I just pick one and write to one of them? I'm sure that will be fine. I do want to know. Oh wait, 5D. I don't have a descriptor or property or whatever that ends in 5D. No, okay. Data. Yeah, good thing there's not a freaking copy the data button. Is this gonna work? Are you gonna give me a nice hex array? No. Oh my gosh. So the copy that this is giving me, it's giving me like the, you know what I'm gonna do? You know what I'm gonna do? I said I wasn't gonna do it. I said you were gonna have to suffer with me while I tried to use packet logger. But they have gone too far this time. The copy function in packet logger copies literally all of this text. Literally all of this text right here. I don't want that. I don't want all of this text. This is like hex editor output. I want the actual data. I want this. It would be nice specifically if it output that as a C array. And you know what can let me copy this as a C array, which is very similar in syntax to a Rust array, is Wireshark. So what we're going to do is I'm going to capture an entire Bluetooth interaction with packet logger. I'm going to export it as a PCAP file, and we're going to open that up in Wireshark. So stop clear. Start. Connect to the LED, and then we are going to go off, on, and we're going to stop. All right. Now what I'm going to do is I'm going to, let's see, I'm going to try and save this. We're going to see if this is going to work for us. If Wireshark can open this BT Snoop file. And I'm going to have to set up a new window capture so that y'all can see Wireshark, because I was not planning on actually using that tonight, even though I told y'all I was, so I apologize for that. You'll have to bear with me for just a moment. Does anyone else in the chat have any interesting opinions on how this library's type system could be structured? Marshall asked about the if we could encode the connection state in the type system, and often that is a really helpful thing to do, but I think just kind of as limitation of this specific problem set, it's really not going to work. But you know, there's plenty of other things that you could do to a type system that could be helpful for letting people use this library. All right, got Wireshark. Let's see if I can open this this thing. No, you don't get to look at my my file explorer. I'm so sorry. Documents. Yes, you can access that. BT Snoop. Beautiful. Would you look at that? Would you look at that? And Wireshark is probably actually going to be smart enough to allow me to do like MAC address filtering. 2F. Oh gosh, I expanded this. I can't do that. I'm sorry. 2F 91E 60 C9 94. No, I wasn't lucky enough to guess the wasn't lucky enough to guess the structure of the Wireshark filtering information. Let's see. There's supposed to be a dialogue. Where's the dialogue? Thought I could, there we go. No. What's that? Oh. Wait, okay, I'm gonna have to Google this. Yes, I am having a great day. Thank you, Alphabet Cereal and Trans Rights. Wireshark Bluetooth MAC address filter. Bluetooth.adder. Wouldn't have guessed that. Not in the list. Okay. Let's see if anything is on the list. Oh, because, oh my, are you serious? That makes me really, that's really annoying. All of the MAC addresses are being reported out as 0. Packet logger has the MAC addresses. They're in the memory of packet logger. Why is it not writing them out in this data format that it's using? That is so annoying. Oh my gosh. Oh, it does. Oh, okay. It does. Wait a minute. 94C961E92. Oh, it's just backwards. Okay. Let's bring the filter back. C961E92F. I'm so sorry for impugning your honor, Wireshark and Packet Logger. What I should have been yelling at is, in fact, it seems the byte order of this stupid controller app. The one that I am doing this stream because I think is bad and I want to re-implement. Okay, beautiful. Characteristic declaration. Yes, characteristics. Okay. Find information. Okay. We sent a write request. Device name, role unknown. Attribute protocol. Unknown. I'm seeing so many unknowns. There's a lot of known unknowns in this problem space. Characteristic configuration client. Reserved indication notification. Notification. So I think it's maybe subscribing to something with this request. I will not be doing this yet. Request in frame 228. Oh, this is the response. I'm so silly. Okay. Send a write request. Yes. Look at this. Look at this right here. Yes. Okay. We're writing data. Writing data. Writing data. That's a lot of data. But that's okay. Copy. Oh, I thought it would give me the data as a C array. That's kind of annoying. Oh well. Let me see if I can let's see if I just write this data. Let's see what happens. I don't remember if I turned it on first or off first. So we're just gonna write the data and see what happens. And if nothing happens, then we'll turn the light, then we'll turn the light off and we'll try writing the same code again. Okay. So I have the service. Oh wait, if I have the UUID, all the UUIDs, I really don't need to do this discovery thing. Because I have the descriptor, I have the service ID, I have the characteristic UUID, because I'm looking at it in Wireshark. Okay, anyways, this is, where did Wireshark go? Hiding from me. Okay, I have the value that I want to write. So let's do LED.write. That line is done. LED.write. And what's it gonna give us? We need to give the write method a characteristic and a data and a write type. The write type is just a normal command. Write type. Oh gosh, does it have a response? I think it actually doesn't have a response. Yeah, it doesn't have a response. And a characteristic. Guess what? We have a service UUID because it's a constant at the top of the file. That was a special tool we were going to use later. You didn't know about that. I knew. Got the service UUID. I mean, wait a minute. This service actually only has one characteristic. So actually, let's just use it. Characteristics dot iter dot and next dot unwrap. Don't tell anyone. Don't tell anyone I'm using unwrap. Characteristic. Okay, and then I just have to feed it the data, which I'm gonna copy right now out of Wireshark, copy value, and I'm just gonna paste this in here, and we're gonna make this a byte string. Oh, and you know what? I actually have the UUID in Wireshark as well. So let me just look at the characteristic UUID. 01 203. Yeah, that is it is the right characteristic. So yeah, I'm gonna write this data and maybe the light's gonna turn on. We'll see. Or off, because it's currently on. It looks like nothing happened. So let's do this. Let's add a little sleep. Let's add a 1 second sleep here at the end. Let's add a 5, yeah. From sex1, and we're just gonna write the very next packet that is in Wireshark. Send write command. There's actually a lot of commands in here, so I actually have no idea what is what, but that's all right. Sometimes it's okay to not know. Sometimes it's okay to guess. And, oh, I see some repeated data in there. Okay, yeah. So we're just gonna copy this other piece of data out of Wireshark. We're gonna paste it directly into VS Code, and we're gonna see what happens if I run this. Hopefully it doesn't break my light. Well, it didn't break my light. Well, maybe it did. Let's see, does the real application work? Oh no, it doesn't. Okay, yes, it does. It does. Okay, false alarm. Everything's fine. Oof. Little moments of panic, but that's okay. Let me look in here. Let's jump back to Wireshark real quick. It looks like these two pieces of data were actually sent in like really short succession with one another. And there was actually there was some data that was sent ahead of time to a different characteristic. Wait, was it a different characteristic? Was it a different service? 1, 2, 3, 4. Wait. The UUID really starts with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 19, 10. I did not notice that. That's very funny to me. Okay. 1910, that is the service that we're connecting to. And I believe, if I remember correctly, it did only have one service, or one characteristic inside of it. So let us see if we could send a different request, actually. Let's see if we can send a request. Characteristic configuration client notification. I want to send that first before any of these other writes. Yeah, there's only one characteristic. Right. This is gonna have a response. And then I guess I maybe need to read a response afterwards. We have the characteristic. I don't feel like there wasn't any data in there. It just looks... It writes to a handle. Okay. I'm gonna look at the BTLTE API notifications. Can I... Oh, I can subscribe to the characteristics. I bet that's what I'm supposed to do. Subscribe to the characteristic. Boop. And then I can probably do something silly like, yeah, I can do this. I can put the LED inside an arc. And then I can spawn a Tokyo task and just listen for new notifications. It's important to put things inside of arcs. I know because the arc salesman told me. Okay, after we've subscribed.
Include. Macro rules include.
No. Tokyo spawn async move while let some notification equals inner notifications. Oh, interesting. Okay. it returns a future. Returns a future that evaluates to a stream. That resolves to a stream. That's kind of a lot, but that's okay. You're gonna make me call the stream methods. You're gonna make me bring in the futures. Great. I'm gonna add futures, and then I can do use futures stream xt. Next. Data wait. I wonder if there's going to be anything interesting in here. Cannot var notifications is mutable. Let's see. Is there going to be anything interesting in here? Find out. Oh crap. That's okay. Maybe it's okay. We'll find out. Oh, interesting. Oh, it's not working. It's trying to connect and it's not working because I have the other app open. So we're just gonna add a little connected message so that I don't panic. And we're gonna remove this sleep because the two things in the like other code that I was looking at happened almost instantaneously with each other in Wireshark. So we're just gonna see what we get. Nothing. We got absolutely nothing. Is it bricked? It's not bricked. Okay. We never read a response off of the thing. It's possible. Well, I imagine this subscribe thing is doing that. Send, subscribe, wait for an okay. Okay. I imagine that's doing the actual work that I care about. We're just going to go ahead and assume that. It's probably, it might be a safe assumption. I don't know. But we'll see. Let's jump back over to Wireshark, and I'm looking again at this data that's being exchanged from the computer to the device. So the computer is localhost, the device is this Zhongsha and a MAC address. So it sends these two packets of information within pretty quick succession of each other, right? It's like within, it's within, a tenth of a second. Oh wait, I'm sorry. Yeah, it's within 0.2 of a second. I'm sorry. 64 to 79. I mean, it's possible. It seems unlikely that timing would be significant. Connection parameter update response. I imagine that's going to be negotiated by the library. I probably don't have to do anything. Send another write command. What is this one? 4C54. Let me copy this one also. And we're just gonna make like a list of, actually, let's do this. Test. Okay. We've got all of our write commands. We've got our request, our write request. I believe this is the subscribe that's happening at the beginning. And then later on, we've got our write commands. Can I add a column for this value? Apply the filter, colorize the filter. Yes. Okay. We've got the same data thing that's showing up. Colorize with filter. Doot. Oh, wait a minute. What? Colorize with filter 2. Okay. Oh, interesting. Fascinating. Okay. Okay, and then we have some slightly different data that's in here. So what I'm doing right now is I'm trying to identify the unique commands that are being sent across the wire. I'm sure there's a Wireshark expert who's yelling at me that there's a much easier way to do what I'm doing right now. And to that person, I apologize. Okay, so we have 3 instances of this command right here, this 45CF. We have it at the beginning, and we have another command immediately following it. And we have it in the middle. And then we have two more commands. And then it's at the end again. So I'm wondering if this is some kind of control sequence. I'm wondering if it's like you send this packet and then you send your actual command. But that doesn't make sense because in this case, there's a 2-second gap in between when we send this supposed control packet and when we send the next write command. One thing that I didn't try is I assumed that this sequence would both turn on and off the light, and it might be the case that this is actually a sequence that's required just to turn the light on. And so every time that I've run the program previously, the light has already been on. So what I'm going to do right now is I'm going to turn the light off, and I'm going to try running my Rust program again, and we're going to see if that actually turns it on. It did not turn the light on. Okay, so we're back in Wireshark. I'm looking at the data. I'm wondering if the endiness of the data is different between Wireshark and the Rust library that I'm passing the data to. I'm not 100% sure how exactly to swap that. I mean, I could, of course, just like Google endiness swap or C5409. Interesting. These are the same between those two. I'm so sorry. I'm back in VS Code. Actually, you know what? I'm going to grab all of the different data packets that are sent and I'm going to paste them into VS Code and then we're going to look at them. We're going to put them under the microscope. We're going to really try to examine them and figure out what the heck is going on with these packets. Copy value. Ooh, those seem spicy. I like these. Okay. Yeah, so I have 1, 2, 3, 4 different packets. Cool. Okay, so we've got 4 different packets. And they all have the same prefix. And these 3, which conveniently have the same length, they all have, it seems like, a lot of common data. And these 2 have even more. I'm really confused, though, as to why... I'm confused as to why these wouldn't just, like... Why they wouldn't line up all the way. because I'd never changed the color. It was either on or it was off. So in my mind, there should be like an on packet and an off packet. Let's try writing this one and see what happens. We're just going on a fun little adventure tonight. A whimsical little jape. Nothing. What's the last one? Could it be a checksum? For this thing right here at the end? Be some kind of identifier for the command? I wonder if this byte right here is actually the one that matters. Turning it on or off. I want to record another session and compare it to this one and see if I get the same interactions. Session 1. I don't remember if the light started on or off the last time I did the recording. I feel like I should probably have written that down, but that's okay. Ready. Jumping over to Packet Logger once again, our favorite software. Let's start recording. Let's connect. Let's turn the light on. Let's turn the light off. And we'll stop recording. And we'll save Bluetooth light thing. Second recording started off. Beautiful. And now let's open that up in Wireshark. Nice. Nice. So we've saved our filter, which is good, and we're still seeing that the different coloring, which is good. Okay, so this is the subscribe right here, and then okay, these are the commands that we're getting. Oh wait, what's this one up here? Is that the subscribe? Write request. What's the difference between these? Client, different clients. Generic attribute profile. Bluetooth generic attribute profile. Wait a minute, was that the... Oh, was that the other service? No, that's just what the protocol is called. It's called generic attribute profiles. Hmm. Okay. We're writing this one. Oh. Then we're writing that. Which, wait a minute. Wait, why does this have a... Oh my gosh. Is there an easier way to Wireshark colorize field? Coloring rules. Hmm. Can I don't think I can easily do exactly what I want to do, which is mildly annoying, but I'll be okay. Okay, so we send that packet twice. Then we send this one, which is the same as a packet that we sent previously. This is the same length as this one. We're gonna have to get in there, figure out what all this stuff means. It's encouraging, I think, that most of this looks the same, right? So we turned the light on, we turned it off, and we turned it back on again. So we issued 3 commands, and they're not in the same order as last time, which is kind of fascinating. But we issued similar looking commands. And this thing also looks fairly similar to the big scary command that we issued last time. Although this one up here has a 1 in this byte, and this one does not. Has a few differences, and this last bit is different as well. I'm not sure what that means. This could be almost anything. Let's see. 4C540. They all have 4C540 as a prefix. And we've got that much. Wait, I just wanted this one line. And this one line. Just wanted to put these 2 things next to each other, so I could more easily look at the parts that are similar and the parts that are different. There we go. These commands both have this part. Well, everything has this 4C540. These 2 like longer commands both have this thing in them. Wait a minute. Did the light start on in the first session and off in the second session? On, off. Is that current status of the light? Do you have to report its current status to it? Let's run a test. I am going to turn the light on, and I'm going to run another capture. I'm expecting, wait a minute. No, because this command is the same. It's the same every time. It could be an initial state. Hmm. Let's run it again. We can run it again. I'm gonna have the light on, and we're gonna see. We're gonna see if we can make any breakthroughs. It's on. I'm disconnecting, and we're jumping over to Packet Locker. Clearing, and recording, and connecting, and turning off. And you know what? Let's just leave it at that. We're going to stop it there. We're only turning it off. So we should only see the commands required to turn the light off. I've stopped recording. And you know what? I'm going to turn the light back on. Because in theory, if I can replay the correct commands, I should be able to turn it off again from Rust. So let's export this file. This is number 3. I'm not writing a big long string every time. And let us open that up in Wireshark. And once again, we're just going to go in here and we're just going to copy all these write requests out of Wireshark and into VS Code so that I can perhaps more easily analyze them with luck. Copy value 7.4. We're getting that 7.4 string again at the beginning. Getting the big packet. Getting 2 copies of the big packet. Well, back to back in like very, very short succession, half a second one another. Which is interesting. 0.5 parameter update, write command, write command. And we're getting this one, which is FE, and then we're getting this one, which is, it looks like that is, whoops, the big command. Copy, not that one, copy this string value. Color me shocked. We have a repeated thing. We have a repeated thingy. So far in testing, it appeared that oh my gosh. This command has stayed the same between multiple sessions, and it's also changed in the scope of a single session, which is interesting because so far that has not been observed. It's also interesting to me that there are 2 of the shorter commands played in here. I would have expected just one, but I don't know. I would love to be able to looking at Wireshark. Can I add a column for this? As a column. Yes. Okay, that's what I should have done. I apologize to everyone for making you all sit through that. Wait, can I not remove the colorization rule? It's okay. It's okay. So in this instance, we see this short command coming through, and then we have two instances of the long command. Let's look at the timing. We have the 7.4 command. We have the long CF issued twice in really short succession. Really short succession, like less than half a second. And then after that, we have the FE command issued 2 seconds later. Unfortunately, because wait a minute. I wonder if this is part of some, but it's the same length. I wonder if this is part of some like negotiation with the device. And then like this is the actual command. Like I'm just thinking out loud here, right? Because we've got like 3 seconds in between these things. Okay. I'm gonna make a new recording, but I'm gonna put a very deliberate pause. I'm gonna put a 10-second pause in between connecting to the device and turning the light on, because this time I think I just kind of ran through it, and that's making it challenging for me to determine what is part of like a negotiation and what is part of actually telling the device to do something. So we're going to jump back over to packet logger, and we're going to clear, we're going to record, we're going to connect, and then we're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I'm going to turn the device on, and I'm going to stop recording. Save as Bluetooth light thing. And we can open up Bluetooth light thing 4 in Wireshark and jump over to that window. Okay, so I do see a 10-second gap in here. Interestingly, okay, so when it is started off, the sequence always begins with this 474 command as the first thing. But then it's flipped back and forth between the AEC and the 345 CF as the second packet. And I'm not sure which one is supposed to come next, right? It's unclear. And then the 1.2 DF is the final packet. And these are all the same, right? Yeah, they're all the same. Wait, what happened? Okay. Let's try writing 7.4 and then AEC and then 1.2 DF. Yeah. Let's see what happens. What could go wrong? I could break my light. But also maybe not. It could be fun. They're being sent without response. So we're sending 7.4. That's the first one. If anybody knows that I'm just like totally messing up the syntax for like byte strings, or I'm like totally misinterpreting the way that you're supposed to translate. Python array size of 24. And slice of U820. Wait, what? Oh, I see. Beautiful. Yeah, we're sending that one, and then the next one that we're sending is DF. This one. And then I want to turn the light off because that is the situation we're trying to replicate. And then I'm going to run it again. Oh, and wait. I'm going to take these out. We connected, we wrote the information, and nothing happened. Let's try swapping this middle command out for the other middle command. Which was, yeah, the CF one. So just try duplicating. Q. Let's see if this gets us anywhere. Command 1 and Command 2 appear ineffectual. And for AEC 2DF, session 4. And it started off AEC next. That one, and then 2DF. What happened after that? Let's see if I can replicate that series of commands. Perhaps. Okay. I'm not going to make you watch me use packet logger again, but I am going to use packet logger again in the background. Starting off, I'm connecting, waiting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds, and I'm turning the light on, and I'm stopping the logger, and I'm exporting it to Wireshark session 5. Now, let's bring up the Shark. Wireshark 5. 7.4 AEC 2DF is exactly the same as session 4. Starting at 58, 60, 65, 70. It connects, it immediately sends this data, and then every 5 seconds it sends the AEC packet. Is that perhaps an I am still alive, and I am with you, and I care about you, and you're valuable, and you're beautiful light packet? Is that what that means? Maybe? Possibly. I suppose we'll never know. Well, I mean, hopefully we'll know. I would like to know. Let's look at this real quick. So switching our filter from only showing me packets sent from my computer to the device is bringing up, not just data. It's showing us also data that's coming back from the device, and it looks like there is some stuff in here. So the first thing that happens, we sent the 7.4. Immediately after that, we get a value notification back. That's very interesting because it seems to me that in the code that I wrote, I thought that I was subscribing to notifications, but it didn't seem like I was actually getting any results back. I'm wondering if this is some kind of I'm wondering if this is being used by the device, or by the application, I should say, to determine which type of commands it should be sending to the device. We're getting these value notifications from the device periodically. There's one in the beginning. Half a second later, 58, 60, 65, 70, 70. It seems to me like that is probably what is happening here. But why am I not getting these same data back from my own application? Let me try, perhaps, running a capture against my own application, and we'll see if we can perhaps determine if the lack of value notifications coming to my application is a function of me not setting something up correctly, or the library simply not seeing that notification. running packet logger, running my application. Oh, the light is on. I should have started it off. Wait, I did get a notification that time. Oh gosh. I got a bit of data over here. I feel silly for not sharing. I received a notification. It has a UUID and it has this value. I would like to know if this value is the same as the initial value that was received on the other side by the actual application. So let's convert this to hex real quick. I'm sure I know how to do that. Decimal array to hex array. It wants to give me one character at a time. That's wait. No. Do this in Python. Hex. Okay. Hex. Beautiful. 4C 54. How can you do this to me? Beautiful. Okay. This is not R. It's plain text. Thank you. Okay, we received a value notification. Starts with O4C. 4C. There's leading zeros in here. A 3 1 0 B 0 1 5 0 2. Oh god, some of these zeros might be significant. Oh. Oh gosh. Okay. We're so far in the weeds, folks. Okay. There's the command that matches up with the syntax that we care about. 4C54. It has an E there instead of a 0. 0, 3, 0, 3. Is there anything, what are the patterns in this that match up with the other places? Got this. Three. It's the notification that came in for the other one. This was this was 5, this was 6. Trying to keep these all straight. Not trivial, but we will get there perhaps. Session 5 started at 5. 4C54, which appears at the front of every single command. I'm not sure if that's like could be a light ID or something like that. I do have a second light that I could compare the data against, but I'm not sure if I actually kind of care enough to do that at this point. That seems like a lot to go and get that one set up. And I'm wondering how much difference exists. Just waiting. So you know what I'm gonna do actually? We're actually gonna just like let just gonna do that. Just gonna we're gonna turn all the writing off. You know what we're gonna do? We're gonna listen. We're gonna see if we get any data back on this notification stream for the device. Doesn't seem like anything's coming right now. Maybe if I try running, if I try writing this command as kind of the first thing across the wire, that might do it. We're just gonna move this down here. Maybe it needs this command to kind of kick it off. Okay. So we wrote the command, and I'm waiting to stream data back from the device. Waiting for these value notifications to come across the wire. Doesn't seem like that's happening. What happens? What happens if I do that while packet logger is running? Because that's the only other time that came in. No. No, that did not work. Wait a minute. Oh my god. Oh my gosh. Everybody, your girl is very silly. Your girl is extraordinarily silly. Tragically silly. I was not writing the hex value for C54. I was writing the ASCII text for C54 on the wire. I thought I was being so smart. I thought I was being so clever using this B syntax in Rust. I thought everybody would think I was super cool. But no. Nope. I was very incorrect about what I was doing. Yeah, so we're gonna use Python again. And what we're gonna do, we're gonna say, gosh, chunks. Can I do chunks in Python? We're gonna start iterating at 0. We're gonna iterate by 2. 0x plus s x s x plus 1 plus comma space. Print out. That's what I needed to be writing. Not that silly, silly garbage that I actually wrote. So this is actually going to hopefully write the data that I care about. Thankfully, I thought that it might make sense to try looking at the data that I was writing. And let's do cast. Let's very silly. And I am still waiting for a notification, which is probably never going to come. Let's try turning the light off and rerunning this, because this is supposedly the series of commands that are necessary to turn the light on. Oh my god! I did it! I turned the light on. Oh, and I even got a notification. I even got a little thingy. A little present. A friend. Okay. I've turned the light on. Let's see if all those packets were actually necessary, or if we could get away with just one or two of them. Because I'm all for streamlining protocols. I don't need that kind of extra baggage. That baggage was not extra. It was critical. Was waiting for notifications critical as well? Did I have to keep the connection open for long enough to receive a message in order to actually turn it on? Maybe I did. That's curious. Let's put this back on a background task where it belongs. Yeah, and then this, well, I do actually want this to be a loop. While let some notifications. Let's say UUID. And then we've got these three. And then let's just like, let's just have a one shot. Let's just block until we receive at least one kind of thing back in the notification. That's actually not going to work. We'll do that. Unwarp. And RX. We'll put this. See. Oh wait, unwrap. Can't borrow it as mutable. Let's make it mutable. Yes. Beautiful. Killing it. And let's just try running the second command because I'm feeling optimistic. Nine 474 2DF. Looks like they're the same except for the middle packet. Oh, crap. Thank you, Jubilee. I'm apparently missing a semicolon somewhere. There we go. Now there's a semicolon. Thank you for pointing that out, Jubilee. There's an unclosed delimiter. Mismatched closing delimiter. Where? Really? I don't. Ah, there it is. Command 1, there's the notification. And command 2 was also issued, but we didn't actually get it to work. The two notifications had the same UUID. I wonder if they had the same data. Let's add a the hints randomly being all caps is funny. Yes, I suppose it is. Print line. Let's do UUID and then the data UID. Value. Let's see if our notifications have the same data or not. Oh, that time we only got one. Let me see. See if I turn the light off and run these two commands again, if it does anything for me. Off, disconnect, and rerun. At the very least, it should turn on. Oh, and we got a very spicy, beautiful looking packet. That came back. Let's see here. It's very shiny. Yes, I like it when the light turns on. It's all in pursuit of the shiny. CCA is something that came back. Doesn't look like that matches up with anything I've seen before, but it does have the E and the 0303, and it's, I don't know what to call this. 0303, and then a 0. We went from off to on that time. One, two, 8. That is the same. Then we have a 1, 3, 3, CC 5, 1. No idea what that is. But I feel like I'm getting somewhere. It turned on. Shiny. If I can turn it off, I feel like that's going to be a good amount of progress to have made tonight. Turn it on. Maybe I can turn it back off again. That'd be nice. Command 1. Okay, so wait a minute. Yeah, okay. So command 1 is 7.4, and then this thing, and then the 22DF. 947413. All right, let me record a session of turning the light off with the app. So I'm gonna start recording. I'm gonna connect. I'm gonna wait 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm gonna turn it off. And then I'm going to stop recording and disconnect. And we're going to jump back over to my favorite app, Wireshark. And, oh, wait, I didn't overwrite. I didn't overwrite a previous capture, which is good. Let's call this one 9. Beautiful. 83, 84, 87, 93. That 10 seconds, that's good stuff. So we're starting with a 7.4 command, and then this command is sent almost immediately. So I feel like this is a command that says like send me a notification that has the session data in it that I need in order to write the rest of the controls. Thank you, Erica. Will I be uploading the video later? I believe that live streams are going to be like persistent to my account. I hope that's the case. I am not recording this independently. I actually assumed that YouTube was recording it and would be persisting it. If that turns out to not be the case, that would be unfortunate. So maybe it'll be on my YouTube channel later. I'm sorry, I can't give you more information than that. So the light started on and we turned it off. The data that we wrote was 7/4, and then our time break. No, and this was like immediate. And the thing that we wrote here was the CF and the CF and the FE. The FE, this one. There are ways to have it automatically pop up for viewing later, yes. Okay, so we will try to make that happen. I will try to make that happen. My team, which is me. FE 7/4, whatever in the world this thing is, and FE. Sure. This should be turning it off. Yes. Let's see if we can do it. Turn it on. We didn't wait for the second notification, which I feel is possibly what happened there. Let's do that real quick. Turning it off to begin with, and starting the application. We want it to turn on, wait a second, and turn off. It's not connecting. That is because I didn't disconnect from in the other app. I did it. I turned it off. I turned it on. I blinked the light one time. I blinked the light. I did it. Okay. Yay. Loop. Don't need to wait for that anymore because it's an infinite loop. Look at that. It's blinking. I'm blinking the light. Woo! This is so exciting. This is like being in a party. Is this what a discotheque is like? Discotheque. Okay, I'm gonna blink it faster. That didn't work. Oh! It's not prepared for that level of speed, but that's okay. Oh. That's okay. I did it. I blinkened the lights. I blinkified the lights. I feel happy about that. That was an odyssey. That was an adventure. I didn't think it would take me 2 hours to blink the lights. I thought turning it on would come relatively straightforwardly. But you know what? I did something. So I made it turn on. I made it blink. It may have been a 2-second blink, but it was a blink. Blink, blunk. So, I had fun doing this. I think it was good. I do want to continue doing this stream. But I think this is probably the end of the stream for tonight. I want to come back and figure out what in the world these packets actually mean. I want to figure out how I can construct them on my own, and I want to figure out how I can do various colors of light. And then I would also like to figure out how I can control multiple lights at the same time, or semi at the same time. So thank you so much to everybody who stayed on the stream watching my ridiculousness. I appreciate you. And until next time, have a good night.